Hello and welcome to today's stream. I'm Alex Ellis, the founder of OpenFaaS, and shortly be joined by Han, who is one of the developers on the team. What we're going to be showing you today is how to migrate a Python function from AWS Lambda to OpenFaaS and Kubernetes running on Akamai Cloud Computing. Now, Akamai Cloud Computing used to be called Linode, and sometimes the words are used interchangeably. We'll also touch a little bit on some of the core differences between the two platforms and why some of our customers actually want to run on something they can host themselves instead of a completely managed service. So I'm now going to bring on Han from Belgium. Good afternoon, Han.
Good afternoon, Alex. I'm fine, thank you.
I understand you're the person that did the majority of the work on this blog post. You've been getting it all up and running and ready to go today.
Yes, that's correct. I wrote this blog post some time ago and now ready to show everyone how they can use it and apply it to their own functions if they would want to.
And it's not a kind of trivial case, is it's not hello world, and we're using some different services as well. So what makes it something people might want to really tune into and learn about?
No, so it's not one of the basic examples, but we're actually showing a real world use case. So we're having a function, actually an ETL workflow, so extract, transform, and load, where we take video and then use ffmpeg to generate a short video preview by taking samples throughout the video and then stitching them back together.
And this is something that I was doing manually for the OpenFaaS homepage. Initially a designer did it for me, and then later on, I actually wanted to update it. You know, we had the same video for 5 years. Like, well, let's get this updated. And so here you can see it. And you'll also notice this if you head over to YouTube. You'll quite often see you hover over a video. It'll be the thumbnail, and then it'll just start playing little bits of it back to you. And so we think it's probably pretty similar approach and technology to what they have done there. All right, so I'll put your screen up now.
Yes.
And this is a blog post that we've written. It's just before Christmas and has all the code. If anyone wants to try the code, try this out. It's all detailed there.
Yeah, the blog post follows what I will now do on the live stream. So walk through step by step and introduce you to the workflow in the first place. Yeah, I think I will start maybe so I've introduced our use case. This is another example where we generated an 8-second preview from one of your other YouTube videos. And what we actually do is I have a Lambda function running, and this function is triggered by S3. So every time a new video is uploaded to the S3 bucket, this will trigger the Lambda function, and then it will handle the event, get the video from S3, do the sampling, and then upload the video again to a different folder in the bucket. So I can, if you want to, I can start by a quick demo. So this is the video preview function that's deployed on Lambda. And as we can see, there's an S3 trigger configured that looks for new videos that are uploaded. And if we go through the S3 bucket, we will see that right now it should be empty. So let me quickly navigate to that. So buckets.
And this is one of the ways that you can trigger functions in AWS Lambda, isn't it?
Yes, this is one of the supported triggers. So also from SQS events or through the REST gateway, or directly invocate them, and depending on what the function, what the source is, the payload that you receive will be a bit different.
Different format, yeah. Okay.
Yeah, a different format. So yeah, I will start by uploading example video to the input bucket, which is now empty, and that should trigger the stream. So I will use the AWS CLI for that. So S3, I'll copy. I have the video that I showed in the blog post. I've downloaded it from YouTube, and it is in should be here, and then I can upload it to the S3 bucket. So this should start the upload. So we're uploading, and now we should see.
We should have our input video.
Yeah, so we have the input video.
Megs. Yeah,
25 megabytes, and this will trigger our Lambda function. And when it's done, the output should be posted in the output bucket.
Okay. How long does it generally take on here?
It depends on the length of the video. So as you can see, this time it was a pretty short video, so it's quite quick, the Lambda function. And as we can see, we'll have, if we open the URL, so access denied.
Well, it's better to be denied than open to the world. So many security incidents and breaches from badly configured S3 buckets. Maybe you can use the download button.
Yeah, I will.
I don't know, at the top.
Oh, I think the open will also work. Yeah.
Cool. All right.
So the same preview. So pretty.
That's neat, and it all ran in Lambda within their runtime. Okay.
Yeah. So all within the Lambda function. I can also maybe quickly show what the actual function code looks like that is deployed. Oh, so wait, I forgot to include it here. Let me quickly get it.
No problem.
Okay, so here it is.
There's something there that I didn't expect to see, is a Docker file.
Yeah,
because when I first created OpenFaaS 2017, one of my main frustrations was that with Lambda, that you couldn't use Docker. You couldn't use a Docker file to build these. You had to do zip files. I think you are still limited to the AWS blessed set of base images, aren't you?
Yeah, so that's one. If we take a look at the Docker file now that you mention it, so we do create, if we see here, that we are using the Python base images provided by AWS. So you're not free to choose whatever image you want. And there are also some limitations on the image size. So your image can only be 10 gigabytes. And there's also a runtime limit on images, functions that are deployed from container images. So it's limited to 15 minutes only.
Oh, really?
Yeah. So that's,
and that's for an async request, isn't it? Because I think synchronous is still 60 seconds.
I think the limit might have increased also, but I'm not entirely sure.
And then you have this old release ffmpeg. So this isn't like a distribution standard one. This is a third-party build.
Yeah, so I directly fetch a static build from ffmpeg that's then included.
And that's easier just to drop into any Linux distribution, and whether it be Alpine or Debian, isn't it? Then?
So that's a similar approach for other Docker.
With the OpenFaaS one, were you able to use the package from the distribution, or did you do the same thing?
With the OpenFaaS, I used the package from the distribution, so we will see that later, that OpenFaaS support adding additional packages, and so that's another way to do it that I will show you.
That's definitely one thing I'd say is already a nice difference. You'll be able to use a native package that's fully tested upstream. Hi, David. Thanks for tuning in.
So if we then take a quick look at the actual function code, so it uses the Boto tree, the S3 client, and then we allow setting some configurations that are specific to this function. So in this case, the number of samples, the sample duration, and it also supports rescaling the video and the format. So we're not doing anything special here. These can be set through environment variables. So if you want to change them, it is in your actual configuration of your AWS function. But you could get these parameters in other ways as well if you want to be more dynamic in the way you process your videos. And then we actually get the bucket event. And as we can see, the S3 trigger allows us to get the key of the object that was uploaded. And then we use that key to get a pre-signed URL that we can use to download the package, the object. And that URL is then used as the input for the ffmpeg.
Now, one of the things that you explained to me that I thought was really cool about this ffmpeg library was that I don't think you had to download the entire 25 megabyte video, did you, to start processing it? There was a way to stream it gradually so you don't overwhelm the function's memory.
Yeah, so that's what we do by generating the preview URL, and we just pass the URL, and then the library will handle streaming from the pre-signed URL, downloading the video, and then we write it to a temporary file before, in the last step, we then upload the generated video to S3 again.
That's the generated file that gets written to the file system.
Yeah, it's the generated file that gets written.
And I guess with OpenFaaS, you can configure a root file system that's completely read-only. That's a feature we've had for a very long time. So you would need to make sure that goes into the temporary directory, wouldn't you?
Yeah. So as you can see, we generate it, so it will respect the configuration to write to a temporary file. And then in this case, we're just doing the AWS specific stuff. And this is then in a separate file where we have some of the actual code to generate the video. So it uses the ffmpeg Python package that provides some nice ways to actually stream different transformations of your video. And we actually first trim the file. So we take the different samples. That gives us a list of streams, and then we can concatenate them back together again. And then in the next step, we scale the video if that is provided, and then we just write the output to the provided output file.
While we're on this note, I wanted to share in the chat, there was a developer from Netflix that actually did something pretty similar a few years ago, probably about 2018, 19. And what Mr. Conger did was he used ffmpeg to make a contact sheet from a video. So you've made a video preview by picking out individual frames, and it probably wouldn't be much different to actually take those frames and put them into like a contact sheet. You also had a water watermark. So you take this video, and as it is, you're just adding a watermark in the corner. And I think they were the main two. There was a preview that he did as well, and that is actually interesting. So we'll have to have a look and see how similar that is to your code. But he actually used Bash, which I haven't really seen anyone using Bash on Lambda. It is a little bit harder to use. Certainly couldn't do anything as complex as what we've done here.
Yeah, the library that I'm using are just bindings to ffmpeg, so you could also write out similar commands yourself and just invoke them from whatever language you want, or in a Bash script that if you wanted to.
Was there a good place to learn about this library? Were the docs all you needed, or?
Yeah, the docs were really good. All functions are documented there really well. So that was the only place where I had to look to
Great.
To write this up. Okay, so I guess yeah, and then of course, but that's common for the Python. We also have the requirements.txt where we have to define our packages that we need. And in the case of the Docker file, we just have a step where we install them. And that's where I think personally the zip file is a lot more finicky when you have to make sure that all these build artifacts are there and then included in a zip file, zip it, upload it. So can be, the Docker file makes it a lot easier already to deploy functions to AWS. Okay, so that's an overview of the workflow that we have running. And now we can start to take this code and modify it so we can run it on an OpenFaaS deployment.
I suppose one of the things that we haven't really touched on is why people may even want to do this. That was an introduction, wasn't it?
Yeah, that's correct. So, of course, if you deploy a Lambda function, I think a major benefit of OpenFaaS is the portability. So OpenFaaS just runs on top of Kubernetes, so you can deploy it in any cloud or even on-premise.
Could you pull up the blog post, maybe?
Yeah.
Because,
so it was in the introduction. And then, or on FastD even, or single.
Because I've got some Raspberry Pis here, the 4, the 5, and that you can, as an edge location, install this and get pretty much the same experience as you would get from running on Kubernetes in the cloud.
And then there's also the developer experience. While for AWS, you're limited to the languages that they support and have official containers for or an official runtime, OpenFaaS supports running anything that's packaged as a container. So no matter what language you're used to writing, you can use it. And we also have a great set of templates that you can start off for different common languages like Python, Golang, C#. So
I think that's well, that was the story with Lambda before, but they do have the ability to write your own custom runtimes now. But they are more complex, I would say, than writing an OpenFaaS template. With ours, it's a Docker file, probably start some sort of HTTP server in a long-lived process, and then write a handler for it. So you can extend it, but what you can't necessarily do is just use any Docker file you want. So we recently had one of our customers calling into OpenAI and returning a server-sent event streaming response of all of the chat messages that came out of ChatGPT's API. And the message comes 1, 2, 3, 4 words at a time. And with Lambda, that's probably not supported. And if it wasn't supported, let's say it is, but it wasn't, there's not a lot you can do. Well, with OpenFaaS, we've been able to just basically write a Docker file, haven't we, and copy and paste some code into there. As long as it's served on HTTP, we've been able to get that to run through the platform.
Yeah, so any HTTP workload that is stateless can be deployed to OpenFaaS easily. And we also make that easier with the REST API. So no matter where you run, if you're running FASD or on a Kubernetes cluster, it's the same API that you can use to deploy your functions and even other HTTP services. So while we always show creating functions, you could also deploy an existing HTTP service to OpenFaaS if you wanted to, and benefit from all the abstractions that we already have, like the autoscaler and stuff.
You mentioned the REST API and the Go SDK we have for that. With AWS, I have seen people host their customer functions on Lambda as a kind of abstraction. I think Vercel does this. But you get into this sticky scenario where it doesn't scale and you end up having to create multiple AWS accounts, potentially with their own credit cards and billing setup, in order to get enough Lambda functions. And then you have to spread them across and proxy them. And it's a whole lot of work. We have maybe half a dozen customers that host code in OpenFaaS as part of their product. And they use our API to build the function from source, get it deployed, and expose it to the customer. And they're not necessarily hosting functions like, oh, it's a FaaS. They may be doing it as part of a chat experience where it calls into the code, or in one example, for e-commerce, to transform from WordPress into some other e-commerce format.
And then as a next thing, we talked about the API. There's also the ecosystem and how you build and test and then deploy your functions. So we have the FaaS CLI that's also developed by us and works together nicely with the whole ecosystem. So that can be used to deploy functions. It builds your functions, and all functions are defined in a single file, the stack.yaml, we call it, and that allows you to easily deploy the same version to any OpenFaaS deployment.
And then we see in the Lambda world, you have SAM, which was like an afterthought, if you like, and you see the serverless framework, and there's sort of some split between, should you use one, should you use the other, should you use CloudFormation? And I've heard stories of CloudFormation for a single Lambda function taking 15 to 25 minutes just for every update. You'll see when Han gets to it, FaaS CLI up, it's really just a matter of seconds. And there's even a live reload feature that is pretty new, but that also gives you this whole experience, because we own from the top all the way down to the bottom of that stack. We're able to make it work nicely together and just have a very easy learning curve.
Yeah, another thing that you can do that I really like as well is, so we have the local run in the CLI as well, which allows you to just run a single function in isolation locally. But then another really nice thing that's of course not possible with AWS, if you wanted to test your functions on a developer machine more, your complete workflow, even if it consists of multiple functions, you can just deploy OpenFaaS to a local Kubernetes cluster and have it similar to how it would run in production.
So those are all almost like non-functional differences, right? Or potential benefits, unique properties. What about the technical side? Because I know we spent some time in this blog post looking at like technical differences. So what's the handler look like in comparison? What's the upload process, etc.?
Yeah, so actually a bit lower here in the post, I do a comparison between just a simple default Python handler that you get when you use one of the templates from AWS Lambda. So as we mentioned before, you get the event, and depending on the event source, this format of this event might be different. So if it's triggered by REST or through CloudWatch event or SQS, any notification, the format will be different. The biggest difference with OpenFaaS, you will see the handler looks pretty similar, but OpenFaaS always communicates, you accept HTTP requests. So it's a familiar format. You have the headers, the body, and the method. So similar payload, no matter which trigger you use, because just like Lambda, OpenFaaS also allows you to integrate with different triggers for events, like Kafka, or of course the direct HTTP call through the gateway. And we also have a cron connector, so you can invoke your functions on a schedule.
Yeah, I use the cron one for sort of marketing and sales type integrations where people fill out a form and we want to import it. There's a nice blog post on that, and it just runs every 3 hours. If someone fills out a form, I know within that 3-hour block it will end up in the customer relationship manager, and then I can just pop in there and go through them all.
So yeah, if we compare both of these handlers, I think the return, you can also return status code. It's pretty almost similar. It's just the input event structure that's a bit different.
Yeah.
So this makes it quite easy to start migrating any functions if you want to. And also developers who might be familiar with AWS, the structure is really, really similar. So I think we can start looking at actually
there was some of the technical items. So if you just go up a little bit, we won't talk through them one by one now, but folks, if you want to come back later, or if you're watching the recording, pay attention to this section, because this will tell you some of the sort of core differences on the technical side.
Yeah, we mentioned some of them already. Yeah. So for deploying our functions, we'll of course need to have our cluster. We are going to create an Elky cluster, so on Linode or Akamai as the rebranding. I already went ahead and set up a cluster beforehand, so a 3-node cluster. It's how you set it up. You can choose when you want to use Terraform or just through their dashboard. It's really easy. Go to the Kubernetes tab, and here you can just create a cluster, select a region, and then you can add
probably shared CPU is enough, isn't it, for people to use for this kind of demo, I would reckon.
Yeah, for this kind of demo.
It's a bit cheaper as well.
It's a bit cheaper.
Yeah.
And in our previous stream, of course, we showed how to set up a completely production-ready cluster with K3s.
Yep, there's a link for that, and just shared it now, but it's easy to find on the blog. It's one of the recent ones.
So I just created a 3-node cluster with the 2 GB of RAM for each node. And that's what we'll be deploying OpenFaaS to. Okay,
so we're about halfway through our time. So we just think about the next 30 minutes.
Yeah,
we've got the OpenFaaS installation. We're then going to go ahead, deploy the function, configure it with secrets, environment variables, and where's the S3 going to be?
Yeah, so Linode or Akamai also supports object storage. This can be enabled, and you can just create a bucket there. So similar to S3, it's S3 compatible, which makes it really nice. It can use the same Boto3 library that we're already using in our AWS function, and just use it with the Linode object storage. So easy to migrate. And there are, of course, a couple of differences that I need to point out. One thing about the AWS function, the Lambda function, is that when you're accessing other resources on AWS, it's assuming the IAM roles, so you don't have to configure any authentication. It kind of looks like automatically. So it assumes a role when you call other services. Here, of course, you will have to set up a secret and for access keys for your S3. So I think that's probably the biggest change that we had to make to the function migration. So yeah, when you create your bucket, you can just under access create yourself a key pair. So I already did that and saved mine to
okay, great. And so that's something you've done earlier. You've got your secrets ready as text
I've got my secrets, and they're here in the .secrets folder, where I will also create my function. I put them under that folder because that way the local run command expects them in that location, so it's easy to reuse them.
Just remember to put it in ignore anybody that's listening if you do create secrets and have them inside the same folder as the function.
And then I think we can start to look at the OpenFaaS function. So we'll use the fast CLI to create a new function. We'll use the Python HTTP template.
Okay.
So we have a template store, where this is one of our pre-built templates. So we can just pull the template. Yeah, in my case, I already had them cached locally. And then once the template is in place, we can use new to create a new OpenFaaS function. We give it the language, so the template that we want to use, and then give the function a name. So we'll call our function, and that's it. We should see a new folder with the name of the function, and we have our default handler that's scaffolded there. The requirements.
Unit testing with TOCs, but I don't think we have any for this.
No,
this is more of an end-to-end type of function.
And then the stack.yaml file, by default, it names it the same as the function name, but you can rename it where we have, in this case, our function configuration that the fast CLI will use to build and deploy our function. So we'll start by modifying the
container registry.
The container registry that
because every function will always be built to a container, published, and then it gets pulled by Kubernetes in. And so if you're using a private registry, it's often very common. You pre-configure the Kubernetes service account for OpenFaaS with an authentication secret, and then any private images you have can be pulled. But this is just a public temporary registry that we like. It's from the Replicated company. And any image you push there gets deleted after 24 hours. So it's really handy for these demos.
And then we'll go back to our handler. And I think we can probably just almost copy.
Are you going to migrate it live here? You're going to rewrite it, are you? Or do you want to
I
copy
think
it from GitHub?
I have examples on GitHub I can run through as well, but I think we can quickly.
Yeah, if you think we've got time for you to personally migrate it like that, that's cool. That's what people are going to be doing at home, isn't it?
Yeah, that's what I wanted to
Nice.
show. So we just copied the handler over. Of course, don't forget to include any imports and other stuff that's outside. Oh, I've done it a couple of times already today. Accidentally. Why is it doing that? Sorry about that. So I just wanted to include. And then, of course, we're also depending on our preview file. So let's take that as well and just put it in the OpenFaaS function directory, so that it's alongside the handler, and we can import it. So the ffmpeg specific code.
It's nice an approach that. So what Han has done is he said, right, before I migrate this function, I'm going to take as much generic code that's not specific to Lambda or AWS interfaces. I'm going to move that into a separate file. So when I do the migration, I'm really just messing up about with the header and the input and output. But the core of the code, all the utilities are in a separate file that will one for one just get copy and pasted across. And I definitely encourage people to do that first if you can, before then trying to migrate a big complicated function.
Yeah, that makes it a lot easier if you only have to think about changing the actual inputs and assigning them to the correct variables, and then just calling your functions. So the biggest difference here, like I mentioned, is the S3 client. Here we just initialize the default S3 clients, which is configured with defaults to work on AWS, but of course here we want to connect to the Akamai object storage. So a common pattern that we use with OpenFaaS functions is to initialize the client outside of the function so that it can be reused with different function calls. And let me just, so we'll create define a new function. We'll call init S3. Like we mentioned before, we need to have our secret and key. We'll use OpenFaaS secrets for that. So OpenFaaS support secrets. We'll show you how to use them later, but and how to configure them.
Yeah.
But essentially, when you configure the secrets, OpenFaaS and tell a function which secret it needs, OpenFaaS will make them available in the function container under the var OpenFaaS secrets path. So in your code, you can just read any secrets you need from there.
Kubernetes has its own secret store, and that's what we use.
Yes.
In some distributions, I don't know how it is for LKE, those secrets are not necessarily encrypted at rest in its setid. So you will want to check if that's important to you. And it isn't always important for every use case, but if it is, check with your Kubernetes vendor or with your self-hosted installation that you've got encryption at rest set up for those secrets.
And then we can use those keys to create a new session. And then, of course, important difference is that we also need to specify the URL at which our bucket is available, as this won't be the default S3 URL. And in this case, we pass this in as an environment variable that we can set in the function configuration. and then we just initialize the client and return it. So that's what our init method does.
Confidential data, always in a secret. Plain text, anybody could know it. It would be fine if it was published on the front page of a newspaper. Environment variable.
And then at the top of our handler, of course, we'll call our init s3 function with a global. So we'll replace this and just make it a global variable that's initially none. And then the first time this code runs, it will initialize the client if it's not initialized yet. So that's the changes we need for the actual connection to S3. And then, of course, like I mentioned, we'll need to tell our function where it can find the secrets and also the environment variable for the S3 bucket URL. So this can be done in the stack.yaml for the function again. And we have a secret section where we can just include the names of the secrets that the function requires. And then, of course, for environment variables, we have an environment section where you can just have the names of environment variables and their values. So in this case, we'll want the S3 endpoint URL and include it in there.
It's a colon rather than an equals, isn't it?
I'm sorry, yeah. And then,
if anybody wants the reference for stack YAML, that is in our docs, docs.openfaas.com. You'd also find it in several blog posts. And I can't stress highly enough, don't put secrets in environment variables, even if it's just testing or just on your laptop. It will eventually make its way into a cluster, and bad things happen when you share secrets in plain text.
So yeah, the S3, the bucket URL, you can look that up. What the Linode,
we have just over 15 minutes left.
Yeah, I will.
You want to crank it up a gear?
Yes. So that's that, and then we can move on to actually migrating our handler, so we can cope with the new HTTP requests that it now receives instead of the S3 message. So we need a couple of changes there to just read the request and get the information from there. I'm sorry. So in this case, we just get the body that we will now transform as a JSON body, and then we parse the body. We'll have a URL parameter that will be used for the input URL, and then we, same as in the previous function, we get a temporary file for the output, and we also construct the key that we want, where the for the output S3 bucket, so where we want our generated video to end up. So this should not change that much, I think. Yeah, I have an extra debug. And then the rest of our code is actually pretty similar. So nothing special that needs to be changed there. We should still calculate from the input, and then we call our preview library to generate the preview input. And we just upload the file to our new output bucket.
Yeah.
And these are the major changes that needed to be made to migrate our function. So just the way we set up S3 and the way we read the
input. Yeah.
The input. So I can now go ahead and see if
Are you feeling brave enough in the time you've got to run this, or do you want to copy the code out of the working repository?
I will just quickly copy the code from the working repository and replace it to make sure I didn't miss any.
So we're just trying to show people the idea, the approach, right? The thought process, rather than live code this 100%. And so we've taken an example that is a little bit like a fan out. So we've got a video, a long video, and we're taking all of this video and then reducing it down. So maybe it's even like fan in. We're taking a lot of data, reducing it down, and then storing it. And you could do this with anything. Perhaps you have a PDF and you want to load it into your large language model. So you import the document or several documents through the function. You send them over to SageMaker for fine-tuning. And you don't get necessarily a result back, but you know that a model has been improved. So that could be another use case potentially.
Important to, I'll copy this from the other configuration, is to configure, since it's a long-running function, to configure the timeouts for the function. And then I think we can give this a try.
Okay.
So I will start.
Did you hit save? It looked like you still had a icon on there.
So we'll use the local run to try and run this. So this will build the function from the configuration that we have. Oh, of course, I didn't rename the file to stack.yaml, so I have to specify it. So this will build our function and then just start the Docker container locally. I forgot something very important, as we can see
the
here.
Requirements text?
Yeah, the requirements text, and also of course, as we mentioned before, the additional packages that we need
to go into the build.
We support this through build arguments. We can specify additional app packages. So this is the ffmpeg package that we need, and then of course also.
Is this meant to be Python 3 HTTP or HTTP Debian?
This is Python 3 HTTP because the ffmpeg doesn't actually package for Python, doesn't need any build toolchain.
Okay.
So
nice.
It just needs the ffmpeg package to be installed, and it calls
so that's something just to highlight to people. If you've got this far, let's say using NumPy or Pandas or Pillow, and these are all wheels from Python that have to be built from source, or usually have to be built from source. And we tend to say use the Debian version of the Python container than the Alpine. Today we're using the Alpine. It's a bit quicker, a bit smaller, but if you ever need to build anything, it's always worse using Alpine. So you just switch over, put at the end of lang-debian.
So yeah, now if we try this again, so we can just run this again, and it should.
That looks like what we're expecting.
Yep, I think it was probably still cached. That's why the build was so quick on my system now. And then if we take a new, we can invoke the function. I have can show. So I already have a function that's and a video that's uploaded in the S3 bucket. So that's where the URL that we set, we pointed to that video, and then we set the samples and the sample duration as the input. And if we curl our function with this input, it should start generating our video. And something went wrong.
Looks like something nil in the input.
Let me check. I think.
Is there something like bucket that you need to pass as an environment variable, or is
yes.
that coming off the sample?
No, I forgot those environment variables. So
at least you're getting errors back. That's always helpful. FaaS CLI logs will usually tell you everything that you need.
Yeah, that's really useful to see the logs. Also need to point it at the correct bucket that we configured, and also tell it where it needs to put the output.
Nice.
So if I had been running it with watch, I would not have to restart this. It would automatically reload when I change the configuration or the function code.
Yeah.
And we can retry our call now. And we see in the logs that it returned a 200 OK status, and here as well. So we can take a quick look in our object store. And in the output, we should find one that I did already before. And this is the one that we just generated.
I mean, maybe it would be nice to get that back as a JSON body, like a link to the video that's been uploaded.
Yeah, I
have a version. For someone to
I have a version of that function as well, but to keep the code a bit
simpler. Yeah.
Simpler for the blog post that was left out in the migration steps, or it would have become a really long. But that's something you could do. And then we've now tested it locally to deploy it to the OpenFaaS, our OpenFaaS deployment. It's really easy. First, I will, of course, need to port forward, because I've set up my cluster. And then once the OpenFaaS gateway is port forwarded, I can... This is a shortcut that I've set up to actually call FaaS CLI login and first fetch the credentials from OpenFaaS, and then
there's a number of ways that you can access the gateway, particularly because that's on a remote public cluster. We'll have some public IPs, so you could set up ingress, HTTPS record for the gateway, and then that's how you'd invoke as well.
Yeah, that's what we did in our previous live stream. So I can access the gateway, and now if I run FaaS CLI up, also have to specify the YAML file that I want. And then something that I really find is we can tell the FaaS CLI to auto-generate a tag for the image that I will push. So in this case, it will generate a digest as a tag.
So if you show that line pushing video, so you see the colon isn't equals to, it's not equaling latest, which is what we have in the stack YAML. It's actually being automatically generated. And there's another version of this. So ideally, you would be committing into a Git repo. And then another one is tag SHA, and then that will use a stable tag. This is just generated by looking at a digest of all the files that are involved. So if you change one, you get a new digest. And so some clusters are not configured correctly, and you will have like a latest tag. You'll change it, you'll deploy it, and you go, well, why is my new version of the function not there? Well, you use the same tag, right? And so some of the time you can get away with that, but we've just added this so that you never need to even think about it.
And then the up command will, as I see, I forgot something again, will build the image and push it, but of course, and deploy it to OpenFaaS. But of course, we first need to also make sure that the secrets that are required are in our cluster.
Yeah. While Han's doing that, for people that are in live, what questions have you got? For people that are watching this later, you can reach us it's every Wednesday at the moment. And there's a link in the docs. That's our community call. You can drop in, just ask what you want to ask. Tell us about what you're building, what you're working on.
So secrets can also be put in with the fast CLI to create a secret. I will just read them from the local folder where I had them stored. And this will create the secrets in the Kubernetes cluster. So I would expect them to be listed here as well. Try and redeploy our function. And now we can see that it was accepted. And when we list the function, we see that our function is deployed. And then, similar to what we did previously, except of course, we'll have to use the function URL. So the URL to the gateway, this is local, forward to a local port, and then function and the name of the function.
And quite often when you and I run OpenFaaS or any HTTP service, a blog post, docs, we will expose that through an inlets tunnel, which means you get a HTTPS URL on the internet with a public IP, and you just connect the tunnel from within the Kubernetes cluster, connect it from your base machine, from your host, and then you can share that with people, you can log into it, and that's just very convenient.
And of course, I invoked the function synchronously right now, so it will wait until the video is generated. But since we're not expecting any output, it just says OK, and we're uploading the result to the bucket. You could actually also
that's the wrong way around.
I'm sorry.
That's okay.
Also invoke the function asynchronously, and we'll see we'll immediately get the response back, and the request will be queued and handled asynchronously by OpenFaaS.
Sometimes we get the question, like for this async function, or the sync function, why not just submit the entire binary, like a 5 GB image file to the function directly? Why use S3 bucket in between?
I think in a lot of setups, using the S3 bucket can be easier because you most likely need somewhere to send your output as well. But there really is not immediately a reason why you can't stream a request directly to your function and have the actual file streamed in the HTTP request when you do the synchronous invocation.
Yeah, but I mean, perhaps. I mean, maybe it's going for a proxy that does a retry and ends up buffering 5 GB in memory. I would generally say, like, especially for the async function, the maximum you really want to be putting into NAT is probably about 1 MB. And so there's a immediate reason for having a reference instead. Right. So
Yeah.
if we've got the video, we've got, what was it, 8.8 megabytes to start, no, 26 megs. So you wouldn't be able to invoke that asynchronously.
No.
So we put it in S3, we get a reference to it, and we submit like a 1 kilobyte reference, and then we can efficiently just stream the data within the cluster. So that is something, it can be a bit hard to get your head around. It's like, well, should I send this huge binary data to the function directly, or should I use S3? And there's some indirection by having a bucket in there. If you're coming from the S3 world, it's likely that you're used to that. But if you've neither used Lambda nor OpenFaaS in the past, then the best way to do this long-running stuff is always asynchronously. It's always through a kind of a bucket or a database, some kind of storage for the big files, and then a reference or a key is the parameter. Well, we're coming to the end of the video stream now. We've got the most people on the stream, considering we didn't really announce this more than sort of 3 hours before. It's been great to have you all here. If you think about wrapping things up, Han, what else did you want to show? Was there anything else?
No, I think we've covered most of what's also available in the blog post. Of course, if you want to give it a try on your own tempo, you can always revisit the blog post. All the code is in there as well, and I also link to the repo where you can find the complete example.
Okay.
So I think we've done the migration. We can use our function. For simplicity, of course, now we upload, we do manual requests with the URL, but you could also, similar to Lambda, generate an event whenever an object is added to your bucket. At the moment, the Akamai Cloud object stored does not support events, but there are solutions like Minio where you can receive events, HTTP events, whenever an object is uploaded, and use that to kick off this workflow.
Of course. Well, I suppose maybe there's one thing that I could show, and thank you, David. It's always great to have you on the live streams. He likes the use case. Is I could perhaps just show this browser. So just go a bit meta for a minute. So this is the OpenFaaS dashboard for customers. And what you can see is that if you've ever used the old gateway, that was like a legacy application, we keep it around because it is useful. But now we have single sign-on available. And so I can log in with my Gmail and get role-based authentication access to go look at, say, the OpenFaaS system. One of the things we did recently was billing integration. So you can get fine-grained webhooks about functions that are invoked. If we went off and picked a function, let's say, like I think we have a sleep function, and we invoke this. This seems to be the scaled to 0, perhaps. It should take 2 seconds to run.
Alex,
5 seconds to run.
I'm sorry to interrupt, but it's quite small.
Okay. Let me get this a bit bigger.
You're showing it's not a single window that you're showing. It's your complete desktop. I think.
Okay. I got that wrong. Let me share that again. That's better, isn't it? Better?
Yes.
Okay, cool. So, what I want to show you is a sleep function. It's available in an OpenFaaS FN namespace. We've got multiple namespaces, which is great for grouping things. I'm going to invoke it again. It's a 5 seconds invocation, and we built this new UI that's a bit like Postman that helps you see everything that comes in and out of that. And then over on this billing function, we should have had some logs through, unless maybe I've turned that off. Let's have a look at the one that we did then instead, this one. We go over to logs, we can see the output from the function here. Now, this is something that I wanted to show you in the last video. We haven't really had a chance to show you this yet. This is a Grafana dashboard. And the reason why this is important, like with what Han was doing, is how many seconds do you think the function took in the end, Jorgen?
I think
like 8, 32.
Yeah, around 15 seconds maybe at max. Okay. And then when I was doing larger videos, it can take 30 seconds. So it depends on.
So let's say you have something that's running 30 seconds. The traditional auto scaling would never be able to scale that, even though you might have like 100 requests coming in. You will need to scale it because you can only do so many in the RAM you've allocated. What we have is a new way of auto scaling functions for slow running tasks. So this ties in nicely to ffmpeg. It's based upon the concurrent requests. So if I was to deploy Hans function here, input 100 videos, we would actually see, for instance, the sleep function experiencing a load, getting extra replicas, having more CPU being used across the cluster, being able to view the RAM, but importantly, we'd be able to see the average duration in seconds. And this can sometimes be a really important indicator that you've got a bug in the system or problem before you use a seat in production. If the average duration is spiking, that implies a problem. Also, you may have an error. So this function here is giving a 200 back, but if you start to see errors, this is where you'd see it. We had one customer who had a function that was idle. They installed a dashboard. First day, they found out it used 6 CPUs at idle. So this is very important, a very helpful data when you do come to take stuff like you're running there and productionize it. I think did you sort of allude in the blog post that if you're doing that on AWS, you want to install CloudWatch, you've got extra bills to pay for all of that as well for that benefit?
Yeah, so I think CloudWatch is enabled to collect the function logs by default, but depending on how long and how many logs you persist, you get billed for that as well.
Okay, great. Well, I'm going to wrap things up there now, and thanks for all your work on this. If anybody's watching this and you have a function and you really want to run it for longer, you want to be able to debug it locally better, your team has moved to Kubernetes anyway, even if you're still on AWS, because most of our paying customers do use EKS. These are all reasons to start considering something like OpenFaaS. The community edition is what Han used here, so you can get quite far with that. For production, we would recommend OpenFaaS Standard. It just has a few more features, better visibility, etc. But yeah, you know where we are. Every Wednesday at the moment, we're running our community call. Please come along. We'd love to speak to you there. Otherwise, both of us on Twitter and GitHub. All right. And without further ado, I'm going to wrap things up. All right. See you next time.
See you next time. Bye.